Right, good afternoon. So this is a second year in a row I'm here to speak at Hashi Days. So I think I probably did an okay job last year, and they invited me back on stage again. So last year my topic was on platform engineering. It was a pretty hot topic in the DevOps space. This year, like many in our industry, I had to succumb to the pressure of the trend. I'm going to talk about AI, right? So in case you think I'm going to do some prompt engineering hack about AI solution, I'm going to do that. It's actually a sharing about real life experience, implementing a production grade GPU cluster here in Singapore. In fact, it's probably one of the biggest and most advanced GPU cluster here in Singapore. If hardware and liquid cooling and thermodynamics is not your thing, bear with me for the next 30 minutes. I think those can be really insightful for engineers like all of us. Okay, but I do want to do a recap from last year. Last year I was on stage to talk about platform engineering or DevOps, and I kind of coined a term called the cloud delivery platform. How do we divide the experience of deploying solution in the cloud across multiple planes, right? On the left-hand side is what I call the developer plane, and the focus is really around enhancing their developer experience using tools that developers are familiar with. For example, the IDEs, GitLab or GitHub, right? Surround the experience around the sets of tools, right? The second part of the cloud delivery platform, or the plane we call it, is what I call the catalog plane. The plane is really about defining secure infra as code, what we traditionally call golden path, good defaults, and making sure there's a really good template for deployment. That's where HashiCorp solution of Terraform, Packer play a very important role in our deployment. Right? To instantiate the IAC we develop, that's where the cloud resource plane come to play. Right? We kind of push those configuration into the cloud and so instantiate your entire cloud environment to the sets of defined landing zone. To close the loop on our cloud delivery platform, we incorporate a security and observability plane. That's where we also implemented HashiCorp Vault solution to manage our secrets in the cloud environment. And to close things off, right at the bottom is what I call the integration and delivery plane. That's where the entire CI/CD experience can happen in our cloud environment. So when we did that last year, we thought we're all done, right? Pat ourselves on the back and say, look, life goes on, time to further optimize our DevOps processes. Then, like all of us, AI hit us. AI kind of changes almost everything for us, right? Where I come from is HTX. We are a government agency in Singapore. Our mission is to keep Singapore safe and secure. And naturally, the data we process are confidential, right? We have tons of data on premise. We can't possibly take those data and move to the cloud to leverage on AI. So instead of doing that, the question we ask ourselves is, how do you bring AI to the on-premise environment? So from a very cloud-native experience, we're given a new challenge about bringing AI infrastructure to the on-premise environment. That's really the first big challenge for us in the cloud, bring AI to on-premise data. We all know many of the LLMs today are pretty new technology. How secure, how safe are those models? They're quite unknown for all of us, right? So we have two choices. Again, either we send our data to OpenAI, hoping they do their best to secure our data, or we do something different. Why don't we build our own LLMs? Why don't we host model, open source, open weights model on premise, right? In order to participate in the innovation of AI and to de-risk it, the best way for us to do it is to bring the models on-prem, secure it with the whatever guardrails we learn, and continue to learn about AI safety and security while being assured our data is safe and secure. Right? Balancing AI and security is an important part of our strategy. The other demand is really GPU. Right? As far as GPU concerned, there's only a game in town. The stocks is going up like crazy. I think so. Right? And it's hard to get GPUs. Right? It took us way in advance to place order with NVIDIA to get those GPU, even that it takes a long time for those to be delivered. And to get GPU in the cloud is expensive. I give a real math example. The math we work out for us to host a GPU on-premise, including data centers, power, and resources, that costs us around two plus Sing dollars per GPU hour. 2 plus Sing dollars per GPU hour based on H100 as a reference point. If you go out to the commercial cloud, that could range between, say, $5, the cheapest, to $11, right? Even hosted in Singapore. So that is actually 3 to 9 times the cost for us, right? So the math works for us that we have to bring our GPU on-premise and we can do those innovation on-premise for our GPU. And we need to bring LM into a product development lifecycle, right? Whether is it DevOps, product management, software development, how do we incorporate AI and LM into that space? So these are really the challenges, right? And to sort of illustrate that with 2 comparisons, right? It looks like this. If you use API, I'm just using OpenAI as an example. It could be Anthropic, it could be anybody else. If you use API from OpenAI, right? The easy part is calling an API. Maybe there's some challenge in doing a rack, doing fine-tuning for those that are familiar, right? But you look at it from the on-prem sovereign AI perspective, calling API is straightforward. Everybody uses OpenAI standards. But to do rack and fine-tuning is much more complex, right? Things that OpenAI kind of wrap under the hood, we have to implement those ourselves, right? For example, do we have an AI gateway to do security? How do you do speculative to coding? Those who are not familiar with, it's like speculative execution for CPU, right? You kind of say there's a prompt coming in. We kind of guess maybe I'm going out for a walk, and the token is going to be a walk. We kind of guess a few iterations, right? So do that, you can optimize the performance of your prompts and increase latency. We do fine-tuning, whether LoRa or LoRa. These are the technology or techniques we implement ourselves without OpenAI. Now, the more challenging part, as the difficulty goes down, gets more complex as you go down the stack, right? At the inference layer, we need to figure out how to do efficient model serving, right? KV cache is one of it. If those are not familiar, I give a real simple analogy. Every time you send a whole bunch of tokens or words to the AI model, how we cache it so that the AI, the models doesn't need to so-called retrace the memory, just like not to read the sentence again and again and again as we figure out the next token. So we have to think about implementing KB cache. How do you do, and how do you implement things like page attention, right? i.e., right, focus attention on the page rather than the entire book. And also, how do you do distributed inferencing, right? There's a couple of techniques that we do. Tensor parallelism, i.e., sort of distribute your inference across multiple GPU, right? And parallel processing, right? So there are various techniques that we have to implement on-premise ourselves because those are not available and because those are things that wrap up by OpenAI. Then the real hard part for us is how do we do model pre-training? But these are the techniques and skill set that's only belongs to a few frontier foundation model provider. How do you build the skill sets and muscle? We have to partner. We have to partner with the frontier lab to learn those skills. Apparently, when Mark Zuckerberg tried to hire people for OpenAI, right? The amount that's given is 100 million just for onboarding, right? Not for your annual salary, just to join. The joiner fee is 100 million for top AI engineers. In the Singapore government, we can't afford that salary, and we have to find a way to level up our skill set. And the very hard problem I'm trying to solve is how do I build a vertically integrated AI infrastructure? That's difficult, right? To optimize, whoever had done any kind of parallel processing, distributed processing, to optimize for performance is actually a very complex activity. How do you make sure your entire stack is well vertically integrated? So that's really all the challenges of building sovereign AI model. But there's also a harder physical constraint, right? I know you guys are thinking of, I'm going to talk about some software stuff, I'm going to talk a bit about hardware. So for those who have done data centers in our life, right, in the past we used to build 5 kilowatt racks, 10 kilowatt racks, 15 kilowatt racks. Things have changed. You look at the first traditional rack on my left or your right, I can host multiple 2U servers in that rack. But for me to bring in a Blackwell B200, the latest, kind of second latest, right now it's B300 GPU into a same rack. A single DGX B200 will consume 14.3 kilowatt, i.e. we don't have a problem about space anymore. We have a problem about power. There's just not enough power and cooling to host the AI workload. And we have to think about new cooling technology, right? New thermal solution. Immersion cooling, I have a slide later. Direct chip cooling, these are some of the consideration. And the GPU behaviors are very different from CPU. Most of you who run CPU know that probably on a good day, your CPU utilization is about 30-50%, right, on a good day, right? And GPU are hitting close 70-80% constantly throughout the whole day as people does training and inference. So it's super intensive. It's going to draw the power that it needs, right? And the future is no more brighter, right? The latest GPU for NVIDIA, the GB300 Grace Blackwell, requires 140 kilowatt per rack. That's 10 times of power to a single rack, right? And to make things worse, the generation after that, the Vera Rubin, requires 600 kilowatt per rack. And therefore, some of you may know, in the US, people are building gigawatt data center right now because of such constraint, right? Some more pictures on cooling. In a normal air-cooled environment, we call CRAC, right? The data center air conditioner unit, it gives us about 10 to 20 kilowatt cooling, right? We mounted real door heat exchange or servers, i.e. added cooling system to the back of our server rack that increased cooling capacity to 30 to 50 kilowatt. That's what we're using right now. The next iteration, we're doing direct to chip liquid cooling, i.e. you look at the picture on the left, the red and the blue. Blue are liquid water going straight into towards the GPU and come out as and dissipating heat as the liquid leaves the GPU. So direct to chip liquid cooling is one of the key technology we have to implement. So that's at the motherboard level, and the picture on the left is at the rack level, right? So they give us 80 to 100 kilowatt of heat dissipation, right? And the next innovation we're adopting today is what we call immersion cooling. So i.e. we dip GPU into dielectric fluid, so they're non-conductive. You cool the GPU as it dip into oil, right? The way to look at it. And the advantage of that technology is there's no fan, there's no mechanical vibration. That actually increase the lifespan of the GPU. So it gives us more than 100 kilowatt of cooling capacity, and it actually reduces, increase energy efficiency. So for those who are not familiar in the data center space, we have this thing called a PUE, right? i.e. for every kilowatt of power consumed, how much goes into computing and how much goes into cooling. So typical data centers, the green mark guideline is 1.3. That means 100% used for computing, 30% for other stuff, right? The goal is keep it as small as possible, right? The direct to chip, immersion cooling help us to bring down PUE to less than 1.1. For information, most hyperscalers are doing PUE of 1.1 something, right? 1.15, 1.2, at below 1.2, right? That's the standard for hyperscaler. So that's really the challenge for cooling, right? And from a global landscape in terms of power, this is where we are at the moment. There's a research firm called Semi-Analysis. I recommend you go check out the article, fantastic article on CPU, cooling, and chip, everything else. In fact, their office here in Singapore, I think Dan Patel started it. Look at the chart on the screen, right? The blue color represents AI data center capacity. You look at 2022, the blue part is a small part. Over time, the blue part gets much bigger. So the projection is there will demand surge of from 49 to 96 gigawatt of power by 2026. And AI is going to consume 40 gigawatt additional data center power just in the US alone, right? And that's a reality. So power aside, what did we do, right? This is what I've been. So when HashiCorp reached out to me and said, "Can you share at HashiCorp days?" I was busy doing a project. I really had no time to think about it. I just simply say yes, right? Since they're good partners of ours. But this is what I've been cooking at the back end, the massive AI GPU cluster. If you look at the picture on the extreme left or your right, that's our GPU cluster. At the top is the inference engine to build ourselves to do all the tensor pipeline parallelism that I spoke about. GPU runs over Kubernetes. So Kubernetes DevOps engineers, you still have a job in the GPU world, right? And we have the DGX B200. Each of it consists of 2 CPU, 8 GPU, and 1.5 terabyte of high bandwidth memory, right? And all 31, 32 DGX are connected together via NVLink switch, right? To ensure that super high bandwidth within GPU, between every single GPU and the memory, right? At the bottom of it, we leverage on what you call RDMA, right? Remote direct memory access to do model serving, to do KV caching, as well as do checkpoints for whenever you train the model, you do a checkpoint to sort of export the data, right? So that's really the entire GPU stack we bring. The fundamental problem we need to solve is reduce the amount of CPU interrupt so the data can move to memory as fast as possible, right? That's a key part of the design. On the left side, we also learned that the storage technology have changed. For those who have worked on SAN, right? SAN, which is your fiber channel storage, the latest technology we adopt is what we call NVMe over Fabric, right? So they are gamers, you build your own PC, you know about PCIe 4, PCIe 5. The whole goal is how to build the express range direct from compute to memory to disk via NVMe, right? So the NVMe memory allow us to connect via RoCE protocol direct to CPU and storage. So that's the important part of our key technology at the bottom. Of course, we still have a VXLAN at the bottom for EVPN. On top of that, we build up our hyper-converged compute structure, our pair services, continue to run Kubernetes on top, and host our application layer on top, right? As an important part of a technology, we still have to do the security stack. Those doesn't go away. Your DevOps, your identity management, your security, secrets management, privilege access, all these pieces is still required in the GPU world. Just that the stack is much more complex, require much better integration of the technology. So, when we first started in the cloud, we learned a lot of cloud native tooling. The challenge for us is how do we bring all these cloud native practices back to on-prem? I call it the inverse cloud strategy, right? You hire a bunch of DevOps engineers, ask them, say, from tomorrow onwards, you're going to turn my data center and see real servers for yourself, right? They are no more a virtual machine. They do not just exist on the AWS portal, right? See some real stuff. But there's a lot of lessons you can learn from what we learned from cloud. How we develop developer experience, how we implement GitLab and Sonatype for security, right? How do you provide a Kubernetes cloud K8-centric approach, right? By implementing, we use Nutanix, NKP, as well as stream Kubernetes. And whatever we build in Terraform and Helm, those are practices we bring back from our cloud environment to on-prem, right? We leverage on the same experience we did with Packer and Vault and Boundary and bring those experience to the on-premise environment. We learned about GitOps in our cloud environment. How do you bring GitOps to on-premise environment? That's what we did, right? And to elaborate a bit more about the implementation of HashiCorp technology. Vault is a key part of our solution. HashiCorp Vault sits at the center of our secrets management, right? We deploy it on Kubernetes using MetaLB as load balancer, traffic as ingress controller. Of course, we have a standard deployment of Vault leaders and follower. Connected to it, we actually connect to a hardware HSM, something we don't do in the cloud world. We have to figure out in an on-premise environment where the root CA is connected to and unsealed via PKCS Hex 11. Likewise, the root secret or the vault can only be unsealed with the HSM connected. Right, so that is the base deployment. Working with the application, the application will retrieve secrets through the vault so that nobody stores secrets in, hopefully in the Git repository. Likewise, we deploy vault agents to virtual machine. That's where certificates are automatically signed as well as rotated as well. So we implemented from a learning from the cloud, we do auto revision of certificates every 30 days, although our policy states 12 to 24 months. Right? Likewise, for Kubernetes, we implemented VSO, right, the vault secrets operator, to do the secret rotation and injection of secrets to the Kubernetes cluster. At the bottom of it, we also leverage on Vault to do a database encryption for our Postgres databases, as well as encryption to our S3, our storage bucket as well. So that's very much our Vault deployment in the on-premise environment. Likewise, we implemented Boundary. One of the big gap is on-prem, and the integration between Vault and Boundary is quite important for us, right? The use case here where developers, admin, they come in through our load balancer, get authenticated through our OIDC provider. Interestingly, we actually use GitLab as our OIDC provider for on-premise environment. Likewise, Postgres to do a system record and Vault for dynamic secret generation. So through the Boundary controller, the users gain access to the Boundary worker, and from that, they're able to access the different resources on-premise, whether it's through SSH, web, RDP, or GUI client. We implement a particular, and all data, all session recording gets stored in the S3-ish protocol-ish environment. So for those who think S3 is only used for AWS, actually the S3 protocol is quite generally used by various storage provider. They all provide a S3 protocol interface, right? So that's our Boundary deployment. So quick summary, this is how it looks like. We are a multi-cloud provider, right? We run stuff on SaaS or NeoCloud, a GPU cloud provider. We continue to implement commercial cloud. We do sovereign and hybrid cloud, where the cloud are isolated, also on-premise cloud environment. Where what's important is really at the middle. We kind of integrate our observability stack and integrate our cloud delivery platform to make sure there's a level of consistency in our deployment. Likewise, for DevOps tooling and MLOps toolings, regardless of environment, we give our developers a single experience coming to our environment, right? So that's really where we are in terms of implementation. But what are we looking out next? The next thing in the world of AI, agents, right? The big problem that we're scratching our head on, for those who are familiar with MCP and agents, but basically, the whole concept is you have MCP server that interact with your client and LMs, and can tell LMs, I have this set of tools, use set of tools to generate a bunch of actions for me, right? But the question asked ourselves is, agents are taking actions on behalf of users, right? OAuth has indicated that there's a risk of excessive agency for agents. That means, i.e., you have a lot of excessive privileges. So the question asked ourselves, right? There's no solution yet. It's a question I put forth to HashiCorp to solve together with us. Is how can we provide a dynamic, short-life, just-in-time access to agents for API calls? Right? Not a constant access. When we need it, you call MCP server. There'll be multiple MCP server, probably to some agentic framework, and then give them just-in-time access and not a permanent access. Right? Identity. Right? The agents are doing actions on humans' behalf. How do you pass on that identity from a human to the agent? So agent is doing for me, Pan Yong. So the agents can only have privilege that I have. And how do you pass on the identity to the agents? Today, the MCP protocol doesn't address it. There are real needs, there are opportunities for some of this problem to be solved in the AI space, right? How do you make sure the agents are deputizing for the right privileges? And importantly, how do you bring human in the loop? Just like Boundary, we run dynamic access, just-in-time access. Hope you can see where all these are going to. I think there's opportunity where agents got to do something. Depending on the privilege and the scenario, that humans can be brought into the loop and say, yes, please go ahead and execute this action because it only cost me $50, right? But it costs more, there's more risk, maybe there are different levels of authorization. So to solve the agent problem, I think there's a real authorization problem where a solution that I bought, Boundary, could play a significant role in that space, right? So I got 5 minutes left. Just to wrap off my talk, I want to highlight maybe some tips, experiences I learned in building the AI infrastructure. For us, building sovereign AI model isn't a luxury, right? That's for all nations, but if the future is all AI, ability to build models, own models, and manage AI models are actually critical skill set, especially for us as a public sector agency, right? What doesn't change is the scaling law. More data, more GPU means better AI. That's what we learned so far. Until the scaling law changes, that's our biggest lesson. And how do you make data accessible to all the brains? So you think about it, right? Our traditional compute design may not support it. Whenever there's a levels of guardrails or inefficiency through due to protocol, the data are not always accessible. The challenge to solve is how to make sure that when AI need to access data, it's accessible, that we don't have a situation where every rack owns a copy of data, and that copy of data has to pass to different AI models again and again, right? What we learned is data centers have to be modular. Well, my job is to build data centers. The problem you see I have today is data centers need about 18 to 24 months to be built. I need about 3 years to get approval because there's sizable investment. 3 months plus 2 years, 5 years. But the technology will leapfrog in 5 years' time. How do you make sure your data center is modular? Can it come in containers, right? Can you be more agile in terms of deploying power and cooling and various parts of our data centers? So you need to be much more modular. We increasingly see there's a need to have domain-specific AI cluster. If you think about it, there are the models that does speech, that model that does text, that model that does vision, that model that does embodied AI. For those not familiar with embodied AI, these are putting AI into robots and humanoids, right? They are different, and we have to build AI clusters that deal with different latency, different performance, different behavior patterns. The other space is computation biology, because the work we do with forensics, we do with understanding chemicals. There's also a need to build computational biology AI cluster. So there will be more and more AI cluster, not just one for text, but serving different kind of use cases, right? User experience. Believe that we need to vertically integrate the AI better for better user experience. For those who have read the news, Johnny Ive was an early designer of iPhone. I think recently joined with OpenAI, right? I think that's one of the vision OpenAI have seen. They say, look, how do I build a consumer device that actually design around the AI experience? So vertically integrated experience is quite an important part of AI. Many people say software is dead because of AI, but I think it's otherwise. I think I have some conversation with some folks during tea break. I think increasingly developer can be super productive with AI, product manager can be super productive with AI. I think what is possible is still out there. But I think the reality is we look at stuff around vibe coding, look at stuff around using AI for DevOps. I think they can become super duper real, very real, but it's really about leveling our skill set in that journey, right? Believe today the hyperscaler had designed the cloud that's very CPU-centric, very storage-centric, very network-centric. In fact, I think AWS started with S3 as the main service. We believe the future is really could be much more AI-centric because things are very different. You have to rethink the design paradigm, right? So that's my tech tips. I'm pretty sure by the time I come back again, if I ever come back again next year, the world will change, be very different. For those who want to connect me, my linking profile is on the screen. Do connect, we have a chat about AI or whatever you want to do about DevOps as well. So if not, thank you so much for time. I hope it's a useful sharing that you're consuming. Thank you. Yeah.